This lecture is on the fourth sections of chapter 3 is about the chain rule. So the chain rule is the rule that we can use to find the derivative of a composite functions. Let's say if we have a composite functions f of g of x, then the derivative of the composite functions equals to the derivative of f of x in terms of g of x multiple to the derivative of g of x in terms of x, right? So if you know that the functions f of u, right, let y equals to f of u when u equals to g of x. So if the function f of u is differentiable functions of u, and the function u equals to g of x is a differentiable functions of x, then the derivative of f of g of x is a differentiable function of x. And you can find the derivative of y in terms of x equals to the derivative of y in terms of u multiplied to the derivative of u in terms of x. So these are two different ways that you can think of how chain rule works, right? The first one, the first way, you want to substitute g of x by u, and then you find the derivative of y, right, in terms of u, and then you multiply to the derivative of u in terms of x. And then on the second way, you can think of the derivative of like f of g of x is the same as the derivative of f with respect to g of x, and multiply to the derivative of g with respect to x. All right, so the key here is identify u, find the derivative of f prime of u, and then find the derivative of g prime of x. All right, so then you can look at the proof for this rule is provided here. And then in this proof, you gotta use, first you have to use the alternative form of the derivative. So this is the alternative form of the derivative. If you let h of x is the same as f of g of x, then you have to show that for x equals to c, right? Then the derivative of h at x equals to c equals to f prime of g of c times g prime of c. You run into a problem when there's are values of x other than c, such that if you plug c into the g, it will be the same as g of x. Again, x is not the same as g. So this is the problem when you run into. However, in this book, in the appendix A, will show the differentiability of f of g to overcome this problem. In this proof, you will assume that g of x is not the same as g of c for values of x other than c. So with that assumptions, you can use the alternative form of the derivative here, and you multiply. The trick is you multiply to a non-zero form, right? G of x minus g of c here, and then divided by g of x minus g of c. And then you can just squish the order of these two. So you move the g of x minus g of c to the first term, and you move this x minus c to the second term. And then at this point, because g of x is not the same as g of c and x is not the same as c, then you can split this limit here into two different limits. And you can come up with the answer for this limits is gonna be just the derivative of f, right, in terms of g of x. And this is the derivative of g in terms of x. Again, this is the alternative form of the derivative. All right, so we know how chain rule works. We should try to do some example. So the first example is, we look at the example number 11. You want to find the derivative of f of x equals to 1 plus x. Okay, so you can see that first I have to identify what is u, what is f, right, and what is u in terms of the composite functions here. So if you look at these functions, the basic functions of these functions is 1 over x. You look at the basic functions, 1 over x, right? And then you look at the inner functions. What is the inner functions here? Inner function that you can find here should be x plus 1. So because instead of 1 over x, you have 1 over x plus 1. Then the inner functions I call as u equals to x plus 1. So then if you let u equals to x plus 1, these functions here will turn into, so f of u will be 1 over u. As you can see that 1 over u is a basic functions, right? 1 over x. And then at this time, we know how to find, we can use the derivative, we can use a chain rule to find the derivative of f of x. So the chain rule say f prime of x equals to f prime of u times u prime, okay? So I know u is 1 plus x, then u prime, right, is 1. Because in terms of x, u prime is 1, okay? So, but then what is f prime of u? F prime of u is negative 1 over. So then f prime of u is negative 1 over u squared. Because remember, if you have a function f of x equals to 1 over x, then f prime of x is equals to negative 1 over x squared. Okay, so combine these two together, I know that the derivative of the functions here equals to negative 1 over u squared times 1, which is u prime. But then you are finding the derivative of the function f of x in terms of x. You need to replace u by x plus 1. So the final answer should be 1 over x plus 1 squared times 1 is just 1 over x plus 1 squared. All right, now go to the next questions, the next example. This example, I want to find the derivative of the function sine of 2x. Then I know, oh, my outer functions, right? My basic functions, outer functions. Is sine of u. I know that. Now, what is my inner functions? Which is u equals to 2x. Okay. So then the derivative of f of x equals to the derivative of u. So this is f of u equals to sine of u, and u equals to 2x, equals to f prime of u times u prime. Okay. So what is f prime of u? F of u is sine of u, so f prime of u is cosine of u. What is u prime? U equals to 2x, so then u prime equals to 2 times 2. And again, you want to replace u by functions in terms of x, and I know that u equals to 2x, so then I can replace u by 2x times 2. All right, go to the next example. And again, as we know, the drill is we want to find f of u and u, right? So f of u is the outer functions and u is the inner function. So f of u equals to, and then see the outer function is the square root of u. And so that means f prime of u equals to 1 over 2 square root of u. This is one of the basic functions. And then u equals to whatever inside the radical, which is 3x squared minus x plus 1. So then u prime equals to 6x minus 1. Okay, so from here, we can find the derivative of this functions, which is f prime of u, f prime of x, equals to f prime of u times u prime. So f prime of u is 1 over 2 square root of u times u prime is 6x minus 1. Okay, and again, you have to replace u's by the functions in terms of x. So 1 over 2 square root of 3x squared minus x plus 1 multiplied to 6x minus 1. Okay, so this is your answer. Now go to the next one. First, what is f of u? I see that I have something raised to the third power. So f of u can be u cubed, right? Then I know right away f prime of u is 3u squared. What is u? U should be the inner functions here, which is 3x minus 2x squared. Then u prime should be equals to 3 minus 4x. Okay. And then in order to find f prime of x, I take f prime of u times u prime, which is 3u squared times 3 minus 4x, which is equals to u equals to 3x minus 2x squared times 3 minus 4x. This is your answer. All right. Next one. So then you, again, identify what is f of u. And the bigger functions or the outer functions is tangents, no, it's not tangent. Tangent should be the inner functions, should be u squared. Then f prime of u is 2u, right? And then the inner function u equals to the tangents of x. Then u prime equals to secant squared. Secant square x. So then the derivative of f of x here, f prime of x equals to f prime of u times u prime. And then f prime of u is 2u times u prime is secant square of x. And you replace u by tangent of x times secant square of x. All right, let's look at this next example. So in this example, you have natural log of x times x squared plus 1 squared divided by square root of 2x cubed minus 1. You can use the chain rule in order to find these functions. You can say f of u equals to the outer function is ln u, right? And then you can say u equals to whatever inside this natural logarithmic functions x squared plus 1 squared divided by square root of 2x cubed minus 1. And then from here you can find f prime of u, and then you can find u prime, and then you can put them together, f prime of u times u prime, to be your answer. But as you can see that this is a little complicated functions, right? In order to find u prime, you have to use quotient rule, you have to use product rule, which I believe that we can do that way. But I feel like it's a little more, it's a little long doing this way. So maybe I'll try to simplify this function first before I apply any of the rules of differentiations to find the derivative of these functions. So if we want to simplify these functions, remember how to expand. You can use the expansions of logarithmic functions rule in order to simplify it. So I have multiplications here, I have division here, so I know that I can expand natural log of x, right? Plus natural log of x squared plus 1 squared minus natural log of square root of 2x cubed minus 1. Okay, I can simplify it a little bit more further than this. I would say, so natural log is, I cannot simplify it any further, but I can move the 2 into front, natural log of x squared plus 1. Okay, minus, see, this is the square root, so I can bring the 1/2 in front to x cubed minus 1. And the reason why I can bring the 1/2 is, look at this. So if you rewrite this term, is going to be natural log of 2x cubed minus 1 raised to 1/2 due to this radical. Okay, so that means I can bring the 1/2 to the front in order to expand this logarithmic functions. All right, so now is the time when I can try to find the derivative of f of x. So I'm using the sum and the difference rule of the derivative in order to find this derivative. So first, what is the derivative of natural log of x is 1 over x. Second, what is the derivative of 2 natural log of x squared plus 1? I take 2 multiply to the derivative of natural log of x squared plus 1. Okay. Minus 1/2 of the derivative of natural log of 2x cubed minus 1. Okay. The next question is, how can I find the derivative of natural log of x squared plus 1? Again, I can use the chain rule. So the chain rule is, so what is f of u? F of u is natural log of u. U should be x squared plus 1. So this derivative should be, then u prime is 2x, right? And then f prime of u is 1 over u. All right, so then this derivative should be u prime times f prime of u. And then you can see that. Running out of space here, okay. So this will be 1 over x is still 1 over x. And this terms here is gonna be 2 times u prime, which is 2x, and then times 1 over u, which is divided by u is x squared plus 1. Okay. And similarly, I can find the derivative of these functions here using the chain rule. So again, f of u is natural log of u, f prime of u is 1 over u. U is 2x cubed minus 1, u prime is 6x. Okay, then this derivative will be negative 1/2, right, times 6 u prime, which is 6x, and then divided by, multiplies to 1 over u, which is divided by u, and u is 2x cubed minus 1. And I just carry this 1 over x down. Just 1 over x plus. So this is going to be my final answer for the derivative of f prime of x. All right, go to the next example. You have a power of functions, right? Exponential functions 2 to the x. And the derivative of exponential functions a to the x in terms of x is natural log of a times a to the x. So then in order to find the derivative of these functions, you just use this formula here of the derivative of the exponential functions, and it's going to be natural log of 2 times 2 to the x. Okay. Go to the next functions here. Now you have 2 to the 4x. So then you have to use chain rule. And the chain rule says you have to identify the f of u. F of u is 2 to the u, right? And u should be 4x. Okay. Then the derivative of this function equals to f prime of u times u prime, which is, so f prime of u here is natural log of 2 times 2 to the u. And u prime is 4. So f prime of u times u prime is natural log of 2 times 2 to the u times 4. And if you combine them together, you get 2. Natural log 2 of u should be 2 of 4x times natural log of 2 times 4. Should be your answer. All right, go to the next problem. It's a little more complicated problem, but again, you just need to identify the outer functions and the inner functions, and you just like following all the steps. So the outer functions for f of u should be square root of u, right? And the inner function u should be whatever inside the radical, which is sine of 7x plus natural log of 5x. Okay. So now, can you find the derivative of f of u? 1 over 2 square root of u. And what is the u prime? What is the derivative of u in terms of x? And then if you look at this u functions here is another composite functions, then we have to use chain rule again. In order to find chain rule, then you have to identify the outer functions, right? F of u for this one. So the outer functions for this functions f of u is here. Let's say f of u equals to sine of u. Okay. Then u equals to 7x plus natural log of 5 of x. Okay. Then if f of u is sine of u, then f prime of u equals to cosine of u. And then u equals to 7x plus 5x, then u prime here equals to 7 plus the derivative of natural log of 5 of x. Okay. Again, in order to find the natural log of the derivative of natural log 5 of x, you gotta use chain rule again. For this derivative. So if you use chain rule, then f of u equals to natural log of u. and then u equals to 5x. Okay, so if f of u is natural log of u, then f prime of u equals to 1 over u, and u equals to 5x, so then u prime equals to 5. All right, so the derivative of this functions here, of this u prime here, equals to, so this, if you look at this u prime equals to 7 plus the derivative of 5x, then the derivative of natural log of 5 of x is going to be u prime, which is 5, times 1 over u, which is divided by u, and u is 5x. So then you can just get rid of 5. It's going to be 1 over x. So 1 over x is the derivative of natural log of 5x. Then u prime here equals to 7 plus 1 over x. So this u prime equals to 7 plus 1 over x. And once you find this u prime, you have to, again, the reason why we want to find this u prime is because we want to find this u prime up here, right? And this u prime here is going to be f prime of u here, multiplied to u prime here, which is here. So then you can have this answer for this u prime is cosine of u, right, times 7 plus 1 over x. Okay. And u, again, u in this case is sine of 7x plus natural log 5x. So then this u prime here is actually, this u prime is cosine of multiplied to 7 plus 1 over x. Okay. And then again, in order, we want to find this u prime because we want to find the derivative of f of x here. So now we actually can combine everything in order to find the derivative of f of x. The derivative of f of x here equals to f prime of u here, right, multiplied to u prime here. And we know that f prime of u is 1 over 2 square root of u multiplied to u prime, and which is something that we already found here, which is cosine 7x plus natural log of 5x times 2 multiplied to 7 plus 1 over x. Okay. And then you can review the u in terms of sine of 7x plus natural log of 5 of x. Running out of space here. Well, let's use this. So let's go down here. Okay. You have f prime of x equals to 1 over 2 square root of sine 7x plus natural log of 5x. Okay, so that's 1 over 2 square root u times this part here, cosine of 7x plus natural log of 5x, and then multiply to 7 plus 1 over x. So this should be your answer. But if you look at these answers here, you can see the pattern that you can find, right? So first, 1/2 square root of whatever inside the radical multiplied to the derivative of sine of whatever inside this sine functions, which is cosine of the 7x plus ln 5x, and then multiply to the derivative of the most inner functions here, the derivative of 7x plus natural log of 5x. So you can see the patterns, and you have three different functions. The first function is the square root of u. The second function is sine of u. And the last functions that you found is 7x, right? And then natural log of 5 of x here. So there's three highlighted functions that you wanna pay attention to. So use different 1, 2, and 3. Sorry. So you find the derivative of each of the functions in terms of u, and then you just multiply them together. And from here, from this recognitions, from these patterns, I think of chain rule as in terms of boxes where each box contains a particular function contain a nested functions. Let me show you how to find boxes, how to use boxes in order to find the derivative of a composite function using chain rule. So again, let's look at this functions. F of x equals to square root of sine of 7x plus natural log of 5x. Okay. So if I want to use boxes, that means I need to identify my nested functions. So the most inner functions that I would have is maybe natural log of 5x. So I assign natural log of 5x to a box. Put it in a box. Okay. And then I go out to my 7x. So I know that the 7x is another functions, right? And I add to this box, and I create another box here. Okay. And I go out to my outer function, which is sine of x. Put it another. Right, sine of x, and I put it another box here. Okay, and then I go out to the next outer function, like the most outer function, which is the square root of x. And I have to put it in the square root of x. Square root. And this is a box. Okay. You can say it's a square root, or you can say it's just like a power raised to 1/2. Okay. So the square root is equivalent to raised to the power 1/2. All right, so in order to find the derivative of f of x, you can just find the derivative of each box and multiply them together. Okay. So the derivative, as we found that the derivative of natural log of 5x earlier, it should be 1/x, right? Using chain rule, like simple chain rule. And then you multiply to, and then you add, right? I have an add here, additions here, to the derivative of 7x, which is 7. Okay. And then I multiply to, so I'm done with the blue box. I go out to the green box. So to find the derivative of sine, it's just going to be cosine. And then the terms inside of the cosine has to be the blue box, which is 7x plus 5, natural log of 5x. Okay, and it keep multiply, so I am done with the sine box. I'm go out to the 1/2 power box, and I should multiply to the so 1/2 is just going to be 1/2, right? You bring the 1/2 down, and then to take whatever inside of the box sine of 7x plus natural log of 5x, and then you raise to negative 1/2, because 1/2 minus 1 should be negative 1/2. So that you can see that this here is a blue box. This is the derivative of the blue box, and this is the blue box. Okay, and this is the green box. This should be the red box, actually. So this is 1 plus x is the derivative of the black box. And 7 here is the derivative of 7x, right? And then multiply to cosine, which is the derivative of sine, but in terms of the blue box. And then multiply to 1/2 to the negative 1/2, but in terms of the green box. So this is the box methods that help you find the derivative of composite function using chain rule. And again, so finding f prime of x is finding this function, and I put it a prime, right? So the derivative of this box here equals to 1 over x plus 7 multiplied to cosine 7x plus natural log of 5x multiplied to 1/2 of sine of 7x plus natural log 5x raised to negative 1/2. You can see that each of these components here are the derivative of each of the box, right? In terms of the inner box. That's how we use the boxes to find the derivative of each of the composite functions. Here's a video, a short clip that shows how to find the derivative using chain rule with boxes. All right, so the next examples is an examples on how to find the second derivative of a functions. So if you're given a function f of x equals to 5 times 2 minus 7 x to the fourth, you're asked to find the derivative of the second derivative, f double prime of x. How can you do it? First, you have to find the derivative of the function, the first derivative, right? And in this case, we have to use chain rule. And in order to use chain rule, I just have to to find what is f of u. And f of u should be 5 times u to the fourth. And what is u? U is 2 minus 7x. So then f prime of u equals to 5 times 4 u to the 3. And u prime is negative 7, right? Because derivative 2 is 0. So then f prime of u should be equals to f prime of u times u prime, which is equals to, this is 20 u cubed. minus times multiplied by -7, which is -140 u cubed. And you have 140 times u, which is 2 minus x cubed. All right. So this is f prime of u, which f prime of x, which is the first derivative of f of x. Then you can use the first derivative to find the second derivative by take the derivative of the first derivative, which is the second derivative, right? Which means you want to take the derivative of negative 140 times 2 minus 7x cubed. So this is the first derivative, and finding the derivative of the first derivative will give you the derivative of the second derivative. So again, in this case, you want to use chain rule, and you just need to identify f of u, right, equals to negative 140 times u cubed. Then f prime of u is negative 140 times 3 times u squared. And u equals to 2 minus 7x still. So u prime is -7. Okay, so then this questions becomes the derivative of the second derivative of x equals to f prime of u times u prime here. And f prime of u, which is found, is negative 420 u squared times -7. And what is u? Negative 420 times -7 is -2, or positive. Negative and negative will give you positive 2940 times u squared. What is u? U is 2 minus 7x squared. So this is the second derivative of this function's 5 times 2 minus 7x raised to the fourth. Again, this lecture shows you how to use the chain rule, right? What is chain rule? How does chain rule work? And show you some examples on how to use chain rule in order to find the derivative of composite functions.